March 26, 2014. We're here to hear Dick Hutto's last seminar as a faculty member at the University of Montana. This is the flyer that advertised the event. Dick's been on the faculty a long time. Charged the ornithology avian research program. Many graduate students. His career, lots of publications. Is good science also effective science? It's a question we all ask ourselves and we argue over, as we'll see in this presentation by Professor Richard Hutto. Dick Hutto will be giving his last seminar today. People are getting ready to sit and listen.
Before I get to introduce our speaker, an announcement by Dr. Bruner here. So please, that's your. That you said you had an announcement.
No, I'll go ahead and announce.
Oh, I can do this.
I was asking for 30 seconds to call my son to tell him when I was coming home.
Oh,
He's fine.
okay, I got it now. Now this is something I can do on my own. But it is important to note that this is not the Iron Horse, but it is the Top Hat as a different venue. Really, because the Iron Horse isn't good enough for Dr. Hutto. the newly remodeled Top Hat is. And so we look forward to seeing you there immediately after the seminar. I was asked minutes before to introduce this gentleman, and it's actually pretty easy to do. First of all, he's one of the greatest guys in the world. No one should let him go. He's one of the best teachers here. He's one of the nicest people who ever walked on this planet. He can imitate bird songs so well that every time I walk past the exact way. So the only way we communicated when we walked past each other's office for nearly 30 years was I'd be going, and he would do a screech owl, and we'd never talked, but we knew why. Dr. Hutto, Richard Hutto, he did his undergraduate at UCLA. He went off then to Flagstaff, Arizona, to Northern Arizona, and did his master's. And then he went back to UCLA, working with Martin Cody, back in the time when we used to get our journals, smell them together, ooh. And you would see this argument of Simberloff and Strong, or Cody and Diamond, and these were the good old days. I'm sorry. This is when ecology was actually pretty vibrant, and things were throwing it. Now that people like, it's still vibrant. It's awesome. Get over it. Dick has been trying to pull the curtain of Smokey Bear, kind of like the Wizard of Oz, and to essentially reveal who's behind this big, the great and marvelous Oz. But Smokey Bear is actually a charade, and he's been trying to share that with us for many years and try and allow us to understand also the bird biology that's coupled with bioecology. So I have so many little stories. I'm not going to do it. We'll do it at the bar because he needs his time, right? came back from Africa to make sure I was here at this talk. So I just left Africa to hear him, and I'm excited that he's here. Dick. Which button? I got the third.
How long you been
They had
I
candles.
just went on Google and found fire art, and that's the background. I thought it was kind of cool. So yeah, the answer is yeah. And are there any questions? I just want to talk about kind of transformation in my own thinking over the last 20 years or so. And specifically about sort of the process of science and steps in science. And one step I think is kind of missing altogether or ignored in discussions of what constitutes really super powerful, effective science. And that's basically going to be the theme here. So the first thing I want to do is talk about what science is. Science is a process. It is a series of steps that we employ to gain knowledge. And it's not like what the next generation science standards tells me. This is out just now, brand new. It's been years in the making. And now we have our new science standards, and you won't see anything about a scientific method in there. Because from what I gathered, reading, is that people were very bothered, the teaching community, about how rigid science is. It's a lockstep, step one, lab, step two. No, science is much more flowing and creative and this and that. And my comments are, yeah, it's creative, but we'll get to that. To emphasize the fact that science involves nonlinear, creative elements, new standards consist of a framework that includes what scientists do. Here are the 8 practices of science and engineering now in the new framework. It's brand new. We ask questions, we develop, we plan, we analyze, we do math, we construct explanations, we engage in arguments, and we obtain value to communicate. That's what science is. That's BS. That's not what science is. And I'm sorry our teachers are going to be doing this. Science is a linear, lockstep, stepwise process. And I wrote about this in the paper, but the committee didn't pay attention at that time. And I'm anticipating the point of the talk. And that is, to be effective in your science, you have to have somebody hear what you wrote. And so science, even though it is a linear process, it's incredibly creative. People in this room can illustrate that. So let me tell you my view of science. It's a 4-step process. 1, you find something interesting to talk about. 2, you try to explain. Usually that's something non-random, something that occurred not due to chance. Something caused it. Then you come up with alternative explanations. That's step 2. Then step 3, you come up with predictions that each of those explanations generate. If this explanation is true, then this must also be true. If that explanation is true, then that must be true. And the last step is you tease apart which of those is most likely to be true by seeing which predictions hold up and which ones don't. That's the game. And you have to go in those steps. It's a stepwise process. That's how you gain knowledge. And what I want to point out is there's plenty of creativity in science with this stepwise process at every step. So there's lots of flow and incense and things if you want. For example, in this room, find something interesting. I mean, who would think looking at water going up laterally is interesting? Or that plants hugging each other facilitatively, or the wing shapes are interesting. I mean, we're looking at diversity of topics in this room because of diversity of backgrounds, diversity of education, sex, ethnicity, you name it. That's where creativity comes in, step 1. Step 2 is one, Tom talked about this. This is Tom's favorite. He says he thinks this is the most creative step in science. He's one that might, best illustrate this. I mean, he is amazing at coming up with reasons for why we see what we see out there, and turning things upside down. So he'll come by and say, oh, we all think we understand, the evolution of collect science. Well, here, look at this. Oh my God! So he's really good at that game. And the other one, who's really amazing, you know, is Dr. Dial. So we were stuck in the mud for 150 years, thinking flight had to evolve from some ancestor that was a tree dweller that then jumped from branch to branch and glided and then finally got flight. Or it was either that, or it was some, you know, velociraptor running on the ground and then beating its wings and starting to go really fast on the ground. So which is it? Ground up or tree down? Ground up or tree down? 50 years, 100 years, 150 years. Somebody comes along with a new idea, and that's what we do. It's like unbelievable. You know, I keep saying it again. How did you do that? How did you come up with a new idea? And of course, the answer's obvious. Dial was raised in LA. And he ran the back alleys and to get away from the cops. He was climbing the walls. And so the wing-assisted incline running thing just came naturally. But that, again, is about the diversity and the value of diversity in science as our background to give us different insight into what might be an explanation. And then this third one, you know, again, people in this room, like Eric Green, you know, in the field, you know, the John Marin types that go out and are really good at coming up with predictions and then designing experiments, you know, with you know, raptors or whatever to test their alternative hypotheses. So all the way down, there's creativity, creativity, creativity. Even the fourth step, you know, you have these people like Paul Lucas or you know, Dave Patterson or somebody that can do fancy statistics and tease apart or give relative weights to hypotheses, each of which can't be disproven. They all play a role, but we don't know the relative proportion of the role. So lots of creativity. Then I have to give Fred Allendorf. Back when we were zoology, when somebody came in with a pile of papers that they had prepared for reports for some agencies and things, and we're talking about their faculty progress in the research arena, Fred said, that's not research, that's not science, it's not science until it's published. You can't bring that junk in and get it. Well, basically, said so many words. And so from then on, we had to have something in press before we can count it as accomplishment in the scientific part of our research teaching and service. And so I agree with Fred. We all agree. And so step 4 really ought to have at the end there that you gotta write what you find it did, okay? Or else it's not science. So Fred says, now it's science. Well, I want to argue no. Fred's still too narrow. There's something that's as integral a part of the whole process of science as all the rest. And it's going to be about communication. And to illustrate the point I want to make, I'll talk about some of my own work. And it'll show you the process of science and then show you the problem and why I think a 5th step is really important. And so this involves the association of saguaros with Palo Verde, and that was like holding it or something else, Chrysotis maybe. Anyway, saguaros growing with shrubs in the desert. And so if you go down to the desert, you see these interpretive brochures saying, oh, you know, the little saguaro, baby saguaros, they get hugged by the plants and nourished, and then they grow up and be a big saguaro. And so when we went down in field ecology in the 1980s, we thought, oh, that's kind of weird. Has anyone ever shown this? Has anyone even shown that this is a non-random distribution? Has anyone ever done step 1 in science? And so no, nobody had. So we thought, well, let's do it. And so take transects, you pack your lunch, and you hike across the desert. It was awesome. You don't see anyone all day. You just hike your lunch. And every step you say what you have a little meter stick thing, and you tap what's on the ground 2 meters to the right or left, open space. Oh, embroidery. Oh, Larry. Open space. Anyway, you do this, use thousands of these points, and so you get an idea of what's in the desert. And what's in the desert is 62% open space. Then you get various other plants, right? Ambularia, so I guarantee you 62% of the desert's open dirt. Okay. Then if you plot where the saguaros are, they're not, as you would expect if they occurred randomly, they occur with other plants more often than expected due to chance. You can do your little Kaiser if you want. It's non-random. So, yoo-hoo! We did step 1. Now we're into step 2. Why the heck is that the case? And so you come up with your alternative explanations. And there are things like this. Hypothesis 1, 2, 3, 4, 5. First, nurse plants provide the only suitable environment for seed germination. Seeds are everywhere, but the only place they germinate is under these plants. Number two, nurse plants provide shade, which decreases the chance of heat stress or desiccation. Oh, okay. So now the babies are everywhere, and the seeds are everywhere, but the only ones that survive are the ones under the plant because of heat stress. Then it can be because of freezing, hypothesis 3, in winter. We know the northern distribution of saguaros coincides perfectly with the 24-hour period of freeze. Nurse plants on number 4 could provide protection from predation. Or the fifth one came because of my background and interest and experience in the desert had to do with heteromyid rodents that eat seeds, and so I was kind of seeds. And I thought maybe the nurse plants provide refuge from seed predation or provide dispersal sites for seeds. Okay, and what's cool about that idea is when you do predictions from each of these, there's millions of predictions, we just concentrate on the seeds. This is the only one that predicts the seed distribution should be non-random, with most of the seeds under the shrubs and hardly any out of them. Whereas all the rest say seeds should be everywhere. Well, this was so cool because I knew there was a little guide to seeds. No, not many people know this. Yeah, and then there's a saguaro seed. It's like a comma. It's cool. You can actually find these things. And so we set up the thing. We sampled under the shrubs. We sample in the middle here, under the canopy, at the edge of the canopy, and a meter out from the canopy. All right, you get a ton of seeds. Here we are, so we got a lot of data. And then you plot the distribution, and where are the seeds? Boom, under the shrub. We automatically played, we even did strong inference. Strong inference is when you have predictions where no matter what you find, whether the predictions held up or not, something gets dumped. In this case, we just dumped 4 hypotheses like that, and we were left that we couldn't dump. And so, from our understanding, that's what's going on. Now, what's going on? Either animals are out there eating all the seeds here, or somebody's pushing all there. So it's either a seed predation or seed dispersal, non-random dispersal thing. And if you trap mammals in there, so there's Sue and Paul are back there. They haven't changed a bit. So here's Sue and Paul, and Rusty, he's down catching lizards in Baja right now. If you catch pocket mice and kangaroo rats and antelope ground squirrels and things, it turns out if you distribute the traps all over the place in the desert, they tend to occur under the shrubs more often than in the open, which is more dangerous apparently. And so if they're doing seed predation, it's going to be mostly under the shrubs, and you'd expect the opposite distribution. So the patterns probably explain more by bird distribution. These seeds, the fruits come ripe in July. Birds come in, especially white-winged doves. What do? After they eat, what are you going to do as a bird? Sit in the shrub. Then what are you going to do? Then what are you going to do? There's your result. We think that birds are the main reason why you see this non-random pattern. And so we even published. So from Fred's standpoint, we did science. We did the whole thing wonderful. But there was something frustrating a bit. We sort of got into this, thinking about what we were reading, going and looking at brochures, and we thought we really have to have an impact by letting people know that this is kind of a fun story, don't you think? And publishing it in the Southwestern Naturalist ain't gonna cut it. So that's why I think this 5th step is hugely important. You have to identify a target audience, transfer the information, and get some sort of response to claim that you've been successful in something. Now over the beer, we can talk about whether we think this applies to everyone, and every topic, or just conservation, or what. So Fred and Doug and I talked about this a few weeks ago, 2 weeks ago. We thought, you can see it applying pretty well across. And NSF kind of thinks the same thing. That's why they invented the broader impacts, to try to get us to think about this. But the broader impacts originally were so wishy-washy, everybody just claimed, I want to train a student, and now I'm doing broader impacts, and I'll talk to the grade school too. Now, that's kind of not what I think they were after. And they've since reworded, so now you go and read about the broader impacts. The newest wording says the impact has to be activity beyond the research per se that will benefit the nation. So they're looking for their money. That's what they're looking for. This is Republican-driven largely. And they want to know that their dollars are being well spent and they're getting some bang for the buck. And so what's neat about this is NSF is really trying to say effective communication is an integral part of the game. It's not service activity. Service activity is reading papers for others in journals and sitting on committees in school and committees for the university, things like that, and going to giving the talk at the audience. This is research. And so consider this the Saguaro story. But how did we do with our broader impacts? Well, we included student training. Yeah, we did train students. I was a grad student and an undergrad at that paper. Talks at seminars and social professional meetings, grade schools, even a PBS television show. Hey, look at this is cool. Why don't you get 30 seconds here?
Now, one story we've got to tell is the story between birds and the vegetation. In fact, the architecture of the Sonora Desert is created largely by activity of birds.
Yeah. Hey, we even got picked up in Ray Calloway's book. We got the cover. I mean, Calloway's probably the only one who's ever read that paper. And so, you know, by broader impact standards, we did pretty well, I think. We did give ourselves a grade. I say A. You know. Not quite as good as Eric, who does this in broader impact for his itty-bitty IPA for his research animals, but, you know, close. So then here's where the story goes. So I went online last week, said, okay, now I'm going to see whether people picked up on this, right? And so here's the baby saguaros protected by Palo Verde tree, and then I read, wow, seedlings grow slowly during their first few years and are vulnerable. Rodents, rabbits, and birds eat them, and they succumb to desiccation or winter freeze. Nearly all survivors are located in canopies of nurse plants and weather screen herbivore. We just dumped those hypotheses. So this is the problem. How can we be more effective? Why did we do it? Just to entertain ourselves? Probably a lot of that. And others in the field are beginning to pick up on this, especially in the environmental field and conservation field. So up there, Hugh Possingham says if there's an increasing disregard for environmental research, it all has to do with communication of the results. Or NSD, the Ecological Society of America's new vision for ecology. We can no longer afford to say it's enough just to do good science. And then take a look at the names on there. You probably can't see them, but just a pile of NSF program directors, right? Authoring these papers in Frontiers in Ecology and Evolution, basically saying the same thing. You know, we need to transform society, not just sit around and play games. And it's no longer enough to just publish our science, but knowledge has to be communicated in a way that allows policymakers and the public to understand the implications of your work and translate that understanding into action. So why is NSF and the Ecological Society and others picking on us? Why do they pick on the journalists that aren't doing the job? And I think the answer is we have to be involved because we understand it. The journalists don't get the story. And often when we tell the journalists, you know, it gets distorted. And so we have to be involved. Secondly, Sue was pointing out, we have the credibility that the journalist doesn't have. We're the ones they're going to listen to. So we have to be involved. And Jane Lubchenko is basically saying the same thing. Science is more than just knowledge. It's also useful knowledge. I believe passionately science should inform our decisions. So, I think science is a five-part game. We've got to be thinking about this last step. And I do think maybe some fields it's more important maybe than others. I'm not sure. This is what the beer is about. But certainly in wildlife biology, conservation biology, medicine, things like that, people's lives are at stake. Their livelihoods are at stake. If you say something that conflicts with the way they're making a living, it means something. And I discovered that as I started working on fire. Disturbance ecology basically is the thematic area. And it kind of hit me pretty hard when I got into looking at disturbance. Basically, disturbance which is severe, where there's lots of death. That's the definition of disturbance. There has to be lots of death for turnover and change to happen. It's generally viewed negatively worldwide, and especially fire. And when I started getting into fire, here's the sort of thing you would hear.
Part of our national heritage is under threat and on fire tonight.
Our oldest national park is under siege tonight.
The president to declare Yellowstone National Park a national disaster area.
In the summer of 1988, wildfires burned through nearly a third of Yellowstone National Park.
There are a lot of angry people who believe that the National Park Service let the fires burn too freely for too long.
It was somebody's fault, and someone was going to get fired. Several people were going to get fired, all the way up to the director of the department, what is it called, director of the Department of Interior, the park superintendent, but yeah, somebody was at fault for that stuff. And so there's the backdrop when I started working on fire, and so we just began to ask, well, is this really historically a natural sort of process we're looking at there? That does look pretty extreme. You know, maybe the framework that we're working in here is okay. And so we thought, if this kind of change and that kind of transformation is natural, and it's happened forever, things are going to evolve to not just take advantage, but to depend on it. And so there should be plants and animals adapted, maybe even restricted to such conditions. And so this is why I got into the bird work. Birds are, of course, the best tool you could possibly use to look at environmental kind of influences, because they just talk to you, they tell you they're there, they identify themselves, you know, hey, I'm a crow, and I'm a robin, hey, whatever. And so it's pretty easy to get data, and so we got a big long list of birds. There's many, many species that showed up in these burned up forests after the fires of 88, like 100 species that we detected. And so I thought right away, well, this is pretty good. So that was around the early 90s. And this paper came out in 95. There's a big lifetime there. What's the problem, Hutto? Well, part of the problem was, I don't know that a bird list is really going to cut it. Is that really going to say all that much? I mean, after all, you know, so what? I can generate a bird list sitting on the Wilma building downtown that's that long. Does that mean the Wilma building is, you know, evolutionarily important and we got to be concerned about it? No. So what should I show to convince people that this is indicating that severely burned forests are probably an evolutionarily important backdrop? Well, one is most of the species nest there. So we've gathered a bunch of data, additional data, and found that over 60% of the species we found nesting in there. They're not just passing over like they would downtown over the Wilma building. They're using that environment. Two, many of the species, over 15% of them, are nowhere more abundant than in burned forests. Now that one was wild. When I saw these data myself and realized that American robins that are running around outside now on the lawns, nowhere are they more abundant than in a burned forest. That's pretty impressive. And how did I know that? Have I been everywhere? No, I went into the literature and I just found literature where people published bird lists for different vegetation types and just tallied up the proportion of studies that said the bird was there. So it's a weirdo meta-analysis with lots of different methods. Most of the burn data came from my own. Oh, now you're comparing you with everybody else. And so, you know, people are pretty skeptical maybe of this. Third thing, some species were relatively restricted to burn forests. I mean, like, where else are they? At least from these data, I didn't, you know, maybe I'm missing a bunch of vegetation types where the blackbacks are really abundant. But from my initial survey, I couldn't see that they were anywhere else. So, and same with, you know, you could look at morel mushrooms, you can look at the fire moss, you can look at these beetles, you can look at lots of things. You can make the argument, I don't know where they occur except for burn up forests. So I wrote up this paper in 95 finally, after getting all those data together, and said, and had a big section on conservation and management implications, because I think there are implications. If it hits you that they don't occur anywhere else, well, then you got to say, are we maintaining that ecological system on the planet, or are we trying to snuff it out, or what do we do in our management? And so I said fires are clearly beneficial to numerous bird species and apparently necessary for some. Unfortunately, we're not currently managing land to maintain the kind of early successional seral stages that follow stand replacement fires, and hence many fire-dependent plant and animal species. So that was pretty bold, and it took a lot of back and forth with the editor. I said, that's what it is. I'm talking from the data, I'm not just pulling it out of nowhere. That's what the data tell me. And so I got away with it. And what's cool is if the more you can do these factual things in the papers, I'm realizing, the more you can make sound bites that are really cool, the press and others will pick up on it. And so it's become much more creative in the writing part of science that I'm enjoying so much more. So one of the things is I thought, well, since it's sort of sloppy the way I put the data together, let's get better data. So in the ensuing 20 years, we've developed the land bird monitoring program. Now we have 18 to 20,000 points all over northern Idaho and Montana, and we've been everywhere. And we've used exactly the same methods of standing for 10 minutes and listing the birds and tallying up. And so now there's not bias in terms of different methods and different vegetation types and all that kind of thing. And the results are just the same. So I wasn't deceived by my quick and dirty method before with the literature. It's even more impressive when you get the real data. They're at least 20 times more likely to be seen in a burn forest than anywhere else. And if you look at the severity of the burn, so you do your little survey point and say, how toasty is it around here? From not so toasty, mostly green, to really toasty, they like it hot. They like the severe stuff, the stuff that's just ugly. And if some people complain that, oh, you don't know, you missed all the birds in the green stuff because they're hidden, and you just see them out and they open it, it's like, oh, geez. So then you do tape playbacks. If the bird's there, they're going to jump out at you, right, and attack the speaker and stuff. And so, okay, we'll do tape playbacks, and it's even more impressive. They're in the hot stuff. Trust me. Okay, and so these things are kind of the poster birds, the woodpeckers in particular, because they come in to get the beetles and get the trees that are not dead. And it's not just them. So the latest data isn't quite published. Out of Black Mountain, I've been working there now for 10 years. So here's pre-fire data. There's that little block. And then about 10 years after the Blue Mountain Fire, Black Mountain Fire. And then here's severity, from not severe to really severe, right? So I have a temporal spatial landscape there. And every species has a point on that landscape where it's relatively abundant. And you have to have that much data to be able to see the positive response in the species. And it's amazing. I mean, every time, every species I look at, there's somewhere on that landscape where they're really abundant. And Dave Patterson and I playing with this, and statistically speaking, you can identify those points on that landscape where statistically they're more likely to occur than anywhere else. So hollow-sided flycatchers love it hot, and they love it, 4 years after. And house wrens, oh my God, is house wren heaven up there. Dusky grouse, don't tell the hunters where the dusky grouse, they come in, they love the hot stuff, and they love it 8 years old. You know, or tree swallows just love it hot. Or Williamson saxsucker, that's a wild bird, I didn't even tell you about it, so wild. And so bluebirds, it's another poster bird for fire. Look at that, you can't get hotter. It's like we need to turn the oven up even hotter and get a hotter furnace. And here's what Dave's working on is we go from low to high severity and from early to later after the fire, and every species is on there, and he's showing that it's amazing. They all have their own spot where it's best for them, and there's many species that benefit from these severe fires. And so just 2 days ago, this paper comes out by Nancy and John Alexander, where they looked at stuff in Oregon and California. They published this whole thing, and this is all a bunch of birds and their response to fire. And they put all the birds in a bucket and just compare before and after. And they don't see anything because they don't know how to analyze the data. They have sophisticated statistical models. They have one, here you go, Eric, lazuli bunting is the one positive responder. Everybody else is negative or no responder. And they got things on there that they're crazy. Here's house wren. You guys, it's like, so anyway, I know these guys. We're going back and forth. And so you got to know how to look at the data to see the positive response, but it's there. You can even go up to Patty Canyon and see open spots that were created by fire in '77 and find calliope hummingbirds doing things they don't do anywhere else. This is coming out like this week. So this is what we found is these things display like grouse in an arena, displaying each other, these hummingbirds. And all the females come through and mate with the one male, that kind of thing. This whole social system is built around severe fire. So, where am I? Ken took my time.
Oh,
no, I'll be all right. I'll be all right. I'm the only one who can get through 120 slides.
Oh,
So, this is the big point here. Severe disturbance is a natural and necessary ecological process for many species. I think that's pretty safe, and I think the data speak for themselves. And that's a big statement. And the more you think about it, if you really want you to blow your mind, I'll even take another step. Most of the plant and animal species on Earth depend on severe disturbance. You've got to know what time after disturbance. Bluebirds like it 10 years later. The Calliope hummingbird 20 years later when the willows are down. Townsend's warbler 100 years later. If you get a 300-year-old or 400-year-old forest, it's too old. The only way to get back to 100 is to go to 0 and come back to 100. Spotted owls like it 300 years old. They don't like 600-year-old. The only way to keep a 300-year-old forest in good shape is to go back to 0 and come back to 300. Everything is disturbance dependent. Everything. And so the importance of severe disturbance can't be overstated. And I am trying to overstate it. And so, the other thing we've discovered is you can't mess around with the system and expect to see all the magic. So if you go in and cut all the trees after, here's just a bit of our data. Open bars are uncut after the fire. Dark bars cut after fire. Every single species is negatively affected. And every paper ever written shows the same thing. Elaine has for that too, right? Yeah, so. Given these results, then, why are we so ineffective? And here, what happens, as soon as a fire burns, you get senators introducing bills to recover after a catastrophic event, remove the dead and damaged trees, reforest, because our federal land's been damaged. It's not that I'm against cutting trees. It's that there are right places and wrong places to do it. This is the wrong place to be. I'm not against cutting trees. So 3 months ago, here's McClintock coming out of California. They're talking about the Yosemite fire. The Yosemite Rim fire is a tragedy that has destroyed 400 square miles of forest. If any good's going to come out of this, it would be salvaged fire codes. And the conservation organizations drive me bananas. They don't get it. Here's Sierra Club. Wildfire was burning last summer in Yosemite. I get this in the middle. It says, send us money because our parks and wild places are at risk. Make an emergency gift to the Sierra Club to protect Yosemite and our planet. From what? From the most special natural process there is? It's like, I don't get it. This is a conservation organization. Here's the Nature Conservancy. Work to restore the natural role of fire. This is not a natural role when it's severe. It's natural when you light a lighter and it goes through. There's no change. There's no change. There's no change in the plants. There's no change in the animals. And that's what we want to do. Let's get to prescribed fire. Let's not turn anything. Let's say, oh God. And so that's the Nature Conservancy. Here's the Environmental Defense Fund. This guy, Eric Holst, wrote surprising role of salvage logging. Oh my God, we were on him like flies on whatever. Then this guy, John Buckley, with the Citizens for Sierra Environmental Resource Center, says, I've personally stood in the hot burn area and not seen a single surviving conifer as far as the eye can see. I'm saying, well, of course. That's the definition of severe disturbance. What do you expect? And then you get, here's a botanist. Your U.S. Forest Service botanist Jenny Haas from the Stanislaus. If we don't intervene, it will turn to brush. You mean what the Calliope's waiting for? Intervening means salvage logging, clearing, and charred trees that are of no value. And she didn't interview the blackback woodpecker. and replanted. This is a biologist, folks. So publishing is necessary, but it's not effective. And I thought, well, maybe we can create a center where we spend more time trying to do this. And that was my solution. So 10 years ago, we got regentral approval to make the Avian Science Center. And as you see, the mission of the Avian Science Center is to promote ecological awareness and informed decision-making by listening to what birds tell us. And so we did this sort of thing. We go to the Hill, field demonstration in public. We get through for the sake of time. Newspapers, radio, interpretive videos, interpretive trails. A brand new trail in Glacier Park. A brand new story written, Sue wrote, for existing nature trail. K-12 teacher training workshops, high school field ecology, grade school. We did a lot over the last 20 years. So we've tried to reach out. And I'm taking a Compass workshop sponsored by NCEAS and the Wilberforce Foundation. They're inviting 20 fire scientists from around the nation to meet in Seattle next month. And this is going to be awesome, I think. Do you think your science should be useful? Would you like to influence public policy or gain widespread recognition beyond your peers? Or perhaps even sway public opinion and help steer the course of history or human behavior? Whoa! Yeah! That's what I want. And so, make your science matter rather than getting buried in dusty piles of scientific articles and like drifts on shelves and forgotten computer files. Yeah! That's what I want. And so, some of the attention is on communication and the right language, like scientists have to put their work into everyday language, or like this tweet from the American Museum of Natural History. Scientists are in the same boat as poets. You gotta get just the right word. I agree, there's some of that's there. But is this message too complicated? I mean, really? Is that my problem? I couldn't communicate my results? I'll say it again. Severe disturbance is a natural and necessary process for the maintenance of biological diversity, for the maintenance of ecological integrity. I don't think I can reword it anyway to get simpler than that. That's not the problem. This is the problem. This is what I've begun to discover. The problem is, it's about value systems. My research results do not fit within a value system that's predicated upon the belief that severe fire is bad. My research results do not fit within a value system predicated on the belief that severe fire is bad. That's my problem. And I don't quite yet know how to deal with this. I do know this isn't what the Ecological Society was thinking of when they said we need to improve our communication skills. They need to think about it. I also realize this is a well-oiled machine that I'm up against. And there are a lot of interest in making sure that the public believes fires are bad. And it's everywhere. This was the 3rd Street near Good Food Store a few years ago. Unfortunately, they can't run for their lives. Look, a botanist, a plant ecologist did not write that. This was an event that they've been waiting for the last 150 years to be reproductively successful. Whose perspective is this? The tree's perspective or somebody? It wasn't an ecologist they had write that. It came out of the timber group probably. And people like, the executive director of the Society for American Foresters writing the truth is that for more than several decades, suppressing fires have made a heavy buildup of fuel, and now we get severe fire. Severe fire never occurred in the globe before. And so we're publishing things to show that that's a problem for most forest types. And certainly this is a problem. The results are catastrophic. Again, my results don't show that. So we're finding his truth is not my truth. We're talking about different value systems. Unfortunately, commodity-based interests have power, and they're the ones that influence Congress, and this is Bush's Healthy Forest Initiative. It was based on catastrophic fires are causing deteriorating forest conditions. They're not restoring forests, they're deteriorating forests. Therefore, we need to prevent them. And then this is 5 years ago, the Omnibus Public Land Management Act of 2009, which established the Collaborative Forest Landscape Restoration Program. We have $40 million a year coming right here, this region, to make sure that we do everything possible to prevent severe fire. Even though 98% of the forests around here depend on severe fire. This came out in the Mississippi last week. Did you see it? Now Congress studies new way to fund massive wildfires. Let's just call that a disaster, which the public's already predisposed to. It's not a natural restoration process, it's a disaster. If we do that, we can tap into the disaster funds. Now the taxpayer pays for us fighting the fire. That frees up taxpayer dollars that are left in the Forest Service to cut, to prevent the fires in the future. It's your money. This is a disaster. This is worthy of disaster. This is not. This is a disaster. This is not. This is a disaster. This is not. But we've all been duped into thinking it's a disaster. There's the dupe. So, you know who stands to benefit from you believing it's a disaster? This is a bigger than me. This is a way of life. This is industry. And because we all believe it, this is what we think we need to do. 90% of the public surveyed in the Bitterroot after the Bitterroot fires in 2000 believe we need to get in there and get that stuff out because there's no value of it. So when I stand in a forest like this and see this beautiful restoration that just occurred, I'm perplexed with what to do. But I understand now what I'm up against. And I think I understand what Darwin was up against. You know, we were all taught as undergrads, oh yes, Charles Darwin, it took 20 years to get the results out. It took so long, you're so meticulous. You got to have your things in order if you're going to be a scientist. That's not what Darwin was up against. You know, his wife was yelling, Chuck, you put that out. I ain't going to talk to you again. And we're certainly not going to go to church if you put that out. And so, you know what he's up against. He's up against a worldview that was different than what his results were saying. Change was what he was finding and suggesting, and that was not the worldview. And to this day, people have a problem with natural selection. And so I think I have, it's been 20 years already, I probably have 20 more years of life left. It's going to be at least that 20 years, you know, continuing to fight this battle. And it can be rough. So here's a young master's student who published a study showing salvage logging is bad for tree recruitment, and all the faculty in his department of Oregon State wrote letters to Science to try to snuff that article before it got published. And the editor-in-chief, Don Kennedy, says, yeah, it's fairly clear this letter was an effort to suppress the paper. And eventually the student was called to Congress, had to testify and defend himself with the statistics in front of Congress. It can get ugly. And so some friends have come out with really good studies showing that, come on, severe fires in every forest type, all the way down to the dry forests in the lower elevation. And then as soon as they write it, these people come out with a rebut, you know, to knock them down. And then the high country news catches it because they love catfights. Oh yeah, here are these two people fighting. And so they interview, and Peter Brown, fire ecologist, says equates Baker with the creationists trying to tear down evolution. So that's the kind of stuff we're facing. You got to be kind of like me and have pretty darn thick skin and sort of enjoy it, or you can pull back into the closet fast. And Baker has really been effective. But we all got together. This took it took 2 years. This just came out last month. This is awesome. We looked at the Forest Service's own FIA data, and it shows clearly evidence of importance of severe fire in the lowest elevation dry forest types, ponderosa pine and mixed conifer forest types. And we end up saying that, you know, current attempts to restore forests to open low severity fire conditions may not align with historical reference conditions in most ponderosa pine and mixed conifer forests in North America. And so the ED picked it up. Boulder Weekly picked it up. Fire Severity Study challenges conventional wisdom on preventing severe fire. So it's good. We're getting that. We haven't hit the backlash yet. And then we continue to try to publish notes to wildlife professionals and others, change your view of fire and that kind of thing. And I'll play you one more thing, and then we're about there. So yeah, I write a lot of letters to the editor. You can't be afraid to do that. You don't sign your name to it. It's embarrassing, but you do it. And so what's really creative is trying to get sentences that you love. And so this I've come to enjoy much more than all the other parts of the science that I do. So like this one, hardly anyone rejoices when they hear a catastrophic fire raging through the forest. And yet, fact is that the hottest, most severe is as ecologically necessary and beneficial for western forests as is rainfall and sunlight. So listen to this radio interview up here. I got a little snippet, and then the congressman.
One of our biggest concerns is future fires in this area. So if we leave all that material on the ground, the severity of those fires would be so intense we would actually have a lot more damage to our soil resource.
She says a team of scientists oversaw the plan. Timber revenue would go toward replanting and other recovery projects. But some biologists oppose any logging. University of Montana professor Richard Hutto says the forest should recover naturally, and snags, or burned trees, attract legions of insects that in turn feed wildlife like the black-backed woodpecker.
Some of these species are fairly restricted to these burned forest conditions. If you don't leave these places alone, there's nowhere else for them to be.
The Forest Service plan is expected to be finalized this summer, but Congressman Tom McClintock, a Republican whose district includes the burn area, says that's too late. He introduced a bill to expedite salvage logging by suspending the environmental reviews.
What the left wants is a policy of benign neglect. They want to let 250,000 acres of destroyed timber rot in place and surrender the ravaged land to beetles and watch as the forest ecosystem is replaced by scrub brush.
Well, now you get the problem. That's what I kind of feel like. That's sort of my style of science. But I'll just end here because we're out of time. What I've discovered is joining with other friends who are like-minded has been really satisfying. And we, some of you signed this letter, 202 scientists sent to Congress opposing the salvage logging, and then the New York Times editorial board picked up on it and said President Obama should rightly veto any salvage logging bill that reaches his desk. And this is success to me in science, not the publication that I got out of conservation biology. This is cool. This could influence what we do and what happens to the planet in the future, and I think that's what I'm trying to get at here. So, yeah, I'm not going to do that. And so this came out several days ago. I think we're making progress. Oh, no, those who venture to Yosemite National Park for the arrival of spring are getting shocked on driving the park. The sight of the rimfire zone feels like getting punched in the gut. So the take home is I think science is more than the 4-step thing. I think it's the 5 steps. I think you got to include transferring information and getting response to your research that you do. And I find that this is probably the most satisfying part of the whole 5-step process I've discovered is actually the time I've spent and the people that I've met and the interactions I have with colleagues that are working on the step 5. I'm much closer to those people. They're almost like soulmates compared to the people I collaborate with on other parts of the science. It's really been interesting. So that's it. Take questions.
If you have to leave, go ahead. Please do so respectfully, but leave.
Sorry, I was a little over.
And then, why don't we take a few minutes for questions, and then we'll definitely continue
top
over
hat,
at the top hat.
Yeah.
Top hat. Top hat.
So go ahead, hit me up with Anna.
So I agree with you that it needs to be discriminated, but I think the problem is who should do that and how we should do that. We cannot do everything, we cannot run everything, and time and money is limited. We're spending, the amount of energy that it takes to do this. We cannot do it now. And so I do resent sometimes a little bit, and I'm trying to come out without this grandeur, please let the God let the thing.
Yep.
So.
Yeah, and all I would say is I think we still need to step a little more into that arena than we do. That's all I would say. And the more I view this as part of the process, part of the entire game we're responsible for as scientists, the more I make
For
time.
instance, the Avian Science Center, so I think that this should be sort of a part of the responsibility of the university to talk on outreach, not only for Rutgers, but all science and outreach science. And I think that's our job.
And that's what the School of Journalism has become. Right? So we're yeah. So, you know, I think there are ways we can marry different departments to help each other in that.
Because we know how to do 1 to 5 and we try to do the best. We are not trained to communicate. We are trained to do 1 to 5.
But I still go back to the statement that we know our work best, and we know the implications. And the press has their story written before they get in your office, and they don't want to hear. They know what they want to write, and unless you make really good friends, and so now there are people working for you. So a lot of those people that we're showing at the end, I feel like they're working for me. So like in Montana, is Montana here? Where's Montana? She's gonna come. She's doing her PhD. It's like you feel like, oh, how people working for you. And so I think you can spread things out and have others help you achieve those goals.
I was just going to I don't disagree with anything you said. I do think large forces are at work, but the challenge is we know only too well. I just read an article in the paper this week that started with the headline, Obama uses geeky graphs to demonstrate the importance of climate science. Geeky graphs. And then further on in the article, basically there was a big discussion about how basically many Americans just distrust scientists. And so like, if science says it, I don't believe it, because...
And that's why I like to emphasize the fact that this is a value system. And I can take anyone into the field of any value, in 20 minutes, they're going to get the story. All I have to do is go out and point to that black back, and you can see them becoming converted and understand that there's a different perspective.
It's not quite that simple, though, because I could go to Yellowstone and have one person come out into the field with the employee of Wolves and say, look what they do, just because I'm just telling you to believe.
Yeah.
And someone else can tell me the exact opposite.
Yeah. And that's the problem. Yep. So Ray and Vicky.
I mean, you see, look, there's two kind of inherent problems. One, the first 4, I like 5. We all love 5.
Yeah.
But 5 is not science. 5 is your value system. I mean, science is a way of doing things and acquiring knowledge. 5 is the value system.
No. This is where I disagree. 5 and the way NSF is beginning to say it is.
You just had it out.
No.
Let me finish.
Wait. What we're saying is, you tell me when you apply for your NSF money in your project, who your target audience is. This isn't value system. Who's your target audience? Are you writing for other scientists? Are you writing for teachers? Are you writing for the public at large? Who are you writing for? And then tell me what it is you want them to do in response to that, and I'm going to measure it.
I'm talking about the process of acquiring knowledge. You tack the value onto that, and you call it science. And I don't think that you can do that. NSF can do it. They do whatever they want, but they can't necessarily call it the process of doing science as the first 4.
Just communication is all I'm talking about. That's not values. That's not values.
But it's not necessarily 0.5 and so.
It is science. Communicating
It's
results is.
the science of communicating, but it's not the science of doing something.
Well, this is where it's interesting. This is interesting because I understand where you're at.
I'm not done yet. The other problem is, and I don't think there's any getting away from it, but one of the reasons the public may not trust scientists is because scientists are so busy trying now to sell their value system, they can't be seen as objective anymore.
Mm-hmm.
And that is, and I don't know a solution to that, but that's an inherent problem. And that's valid in terms of a citizen saying, hell, all I ever hear from the science is their opinion.
Yeah.
You know, of course they're going to find the results that they do.
Right. Okay, so I'll come back there. We're required by law and morally to manage our public lands in a way that they don't compromise the integrity of the ecological system. That's the law. That's not a value system. That's the law. And so I can come back and say, I have results that show you're compromising the integrity of the system. That's what I'm getting. It's not me and my value. It's that you're not following the National Forest Management Act of 1976. That's what
But Dick, if the Republican you mentioned passed a law.
they'll pass another law, but right now the NFMA is in. I know, but the public passed that law. That is the value that we have to follow by law.
But what we're missing is that we need an additional professional category that probably has a PhD in biology or whatever scientific discipline, but that.
Anna, you don't want to get into this communication thing.
I agree with you, but what we cannot do, and if we're going to do a disservice to science in the long run, if we spend 3/4 of our time.
This is beer talk. This is beer talk. This is beer talk. If we go to my lab and look at the journals on the shelves, there's not one of them that's worth an article in there that's worth much of anything. I don't believe we're losing anything if we concentrate on people that have something to say and something meaningful in their science.
Is that we're not communicating?
I know.
We need beer.
I know. No, wait, let's get to Vicki. And yeah, we definitely do.
I'll throw out one comment Brooke Gladstone made, and that is that transparency is the new objectivity. Objectivity is a wonderful thing we strive for, and it's a very important thing to have, but we can be transparent. And I do it when I go and talk at, I'm asked to speak as a scientist on a decision. I bring my citizen hat and my scientist hat. And I say, with my scientist hat on, this is what I think is working and going on. And I put my citizen's hat on, and I say, this is what I think we should do about it.
So can most of what I said, is that my scientist hat? Is that safe to say?
Both at the same time. Yeah. Well, I would say that to the first 4 steps, you have your scientist's hat on, and then you put your citizen's hat on.
I don't know. This needs beer. I don't know.
I one more trick there I would say that speaking as a hydrologist, I have signed on to those anti-salvage logging letters.
Yeah, I know. You signed. Thank you so much.
But to a hydrologist, the scale of a big severe fire, that's an issue because you can burn enough of the watershed that you change the.
I know. I understand. It's more complicated. Jim Habeck is the one who alerted us to the fact that, in some situations, things can be out of whack. I'm sensitive to that, and I understand that there are, there's a range, but I think we've moved this story of things out of whack way into places it doesn't belong. That's my problem. Especially here around Missoula. To say these forests are formed by low understory burns, driving wagon trains through them. So, anyway, yeah.
So, for me, it's pretty frustrating to see that you make all these efforts to communicate how important is this, and then just going into a road, see simple advertisement with a Stevie Bear.
Welcome to my world.
Exactly, that's my world too.
Yeah.
So my question is that for me, all points to the marketing.
Yeah.
All the people that do these advertisements know how to hit people. Why are not, for example, calling to the Coca-Cola company and asking how the heck you did in your time to put Coca-Cola can inside of the mind of all the people in the country when I see only the something like soda. It's not something that we could do.
And we need to look into who's doing the marketing and the advertising and be
somebody
part of
from
that.
there.
I volunteered to be on these communication committees and things with the new National Forest whatever plan, and I'm trying that too. Can I be the next one to write the poster? Anyway.
With all the controversy, some people think it's controversial with climate change, and I'm personifying the public asking this question to you, that wildfires are more frequent due to climate change, and that's unnatural. That's a human activity, and we should be responsible to curtail that in some way.
Yeah, excellent question. Climate change, things are changing, fires are getting bigger. My response to that is that's a climate change issue. That doesn't make fire any less natural than it ever was. Fires driven by climate and weather conditions, especially severe fire. 98% of the land burns is in conditions that are controlled by the weather, not by fuels. And so fire does what it's going to do. If you don't like what it's doing, you don't like the amount and it's getting bigger, then do something about climate change. It's not a fire problem.
How about one more and then we go to beers, okay? You pick who that is.
Oh,
not me.
Two more. Okay, quick.
I think one of the problems that's always on is what are we striving for? All the reading that I've done about archaeology and anthropology and prehistory is that fire was an important part of the landscape and greatly modified the landscape. So exactly what is natural? What is our objective? You know, and I've been struggling with that for a long time, and I still don't know the answer to it. I've been reading a book by Charles Mann called 1491 about what the landscape was, you know, prior to Columbus.
And where I usually go is the plants and animals, and I ask them, because they're carrying an evolutionary history. And everything about them, from their color, from what they do, how their seeds look, has to do with the environment in which they evolved. That's the way to get an understanding of what we should for if we care to maintain the things that we like, those species we like.
So some species are abundant in one habitat and some species are in another, and they've been modified by humans.
Yeah, so the blackback woodpecker says severe fire must have been natural, I wouldn't be here. So that's how I do it. Yeah, last one, and then...
It's more of a comment, really. I think scientists are communicating their science all the time. It's just the public audience that they're choosing to communicate within. And yes, you don't have to go out to that extended public audience, but you do need to know that your science gets into the marketplace of ideas. And if your science is out there, you need to be able to help that audience understand how it interacts with what you do. And that means understanding what your words are. Saying nutrient cycling is nutrient cycling, and I don't care if the public understands what that means, is not the right approach to communicating your science.
That's why we need to work with people like Allison and journalism to figure out that trick. Yeah, sorry.
Thank you, Dick. That was awesome.
Stirred up the
How you doing? Good to see you.
See ya. Oh,
See that website? I did. Yeah, it's been a couple more changes. Oh, it's pretty much. You just go this
Yeah, I'll let you know. I'm going to do like a big email or something. We'll see you again.
I would like a copy of that. I thought that was an acceptable thing.
Well, it's the last one, so.
Yeah, I know. I knew it was going to be good. Well, various places. But I never was a professor. I never was a professor, so I didn't really quite have this thing. I really like it when a professor goes into philosophy at the end of his career.
I better turn this off.
Thanks. Nice to see you, Jim.
Okay, I have your address.
Well, that's actually Dick's address.
Okay.
All right, but they'll get to me because I get his mail.
At the heart of the problem is the journalist right
Well, this is the end of Dick Harrow's lecture here. Standing ovation. All turned out well. Nobody agreed on everything.
Makes it really
Call it quits.